Okay, so in order to graph this piecewise function, we have three different rules, and each take place at different places within the domain of the function, right? So whenever x is less than or equal to 2, it looks like a parabola. Whenever x is between 2 and 5, and then we'll talk about the endpoint specifically, it looks like just a line with a slope of 3. And then when x is greater than 5, it just is a horizontal line. So let's look at how we would do that. So I know that, well, one thing to be aware of is when graphing a piecewise function, we have to be really careful about the transition points, like where it switches from one rule to the next. So like at 2, right? At 2, we're going to have a closed circle actually on this graph and an open circle on this graph. Because what we'll get is if we have an open endpoint where it's just an inequality, the end of the graph should be an open circle, just like it would be on the number line. And if we have a closed endpoint, like this one at 2 or this one at 5, where there is an equal part, you're going to have a solid point to show that that point's included. What is really important, though, is like this, well, say this graph here, 3x plus 1, it's everything bigger than 2 all the way up to 5. But you have to go all the way to 2 and use an open circle because we have to include points like 2.01 or 2.3 points in there. So as we look at this, for our first function, we have x squared, where x is greater than or equal to 2. Sorry, less than or equal to 2. So for this one, I know a standard parabola I probably would go from like -2 up to +2, wouldn't I? Would be reasonable points to use. So then here we'll get 4, 1, 0, 1, 4. Now, these are going to keep going. We're going to keep having x go smaller and smaller. But we know that here at 2 that we're going to have a closed circle. Right, it's going to be a closed endpoint. So let's see what that would look like here. So we have 0, 0, 1, 1, 2, 4 we said was closed, -1, 1, -2, 1. So we have these points, correct? But since this is the end of our domain, this is going to stop as a closed circle. This is going to look like that. That makes sense? So it's this part of the parabola, but it's only drawn from x values 2 or less. Right? It doesn't exist where x values are bigger than 2. Now for our next one is 3x plus 1. For this one, I'm going to put in, well, it's a line. I'm just going to put in the 2 endpoints, right? I'm going to put in 2 for x. I'm going to put in 5. That's actually going to be way off our graph, isn't it? I didn't do a very good job there. So I might have to adjust the graph a little bit. But here, as we look, this one, because it's 2 is less than x, it's going to be an open endpoint. And in this one, since it has a true, or it has the equality part here, this middle one, it's going to be closed. So it's going to go from an open circle to a closed circle. And actually, just to make this easier for us to graph, because otherwise it's going to be way off our graph, let's just make this a 2 right here. We can fix that, right? Executive decision. We'll make it a 2. So we put a 2 in there, we get 5. And then we put a 5 in there, we get 11. We can work with 11. So if I plot these points, 2, 5 is here, and we said that's an open circle, correct? Because that's not, 2 is not part of this domain, but everything just bigger than 2 is, so we use an open circle to indicate that. And then we have a point at 5, 11. So 2, 3, 4, 5. Made sure 11 was up here. And that's going to be a closed circle. And so from here, it looks like that. So it's just that line, right? That line 2x plus 1, but it stops, right? It starts from this closed circle out to this open circle right here. Okay, and then our last part is that f of x equals 5 when x is greater than 5. So for this one, we're going to have another table. So we have x, y, and then we'll put in 5 and 6, put as many points as you want. It's going to be a horizontal line. But this one, it's just a greater than. So this is going to be an open circle. Then we know all the outputs are 5 because that's what that function does, right? Every output's 5. So we have a point at 5, 5, which is open, and then it shades to the right. So that's what our piecewise function would look like here. Now as we look at this, if you think about the domain of this function, does every x value have an output? Looks like it does. You hear everything is 2 and lower. Then this is everything between 2 and up to 5. And this is, but if you notice, are there any places where a vertical line would hit the curve twice? There's really not, because here, even like at 2, there is an open and a closed circle, but remember a closed circle is not really there. Right? Or out here, you have an open and a closed circle. So if you were asked to evaluate f of 5, you would go look at this closed circle here. Right? If you were asked to evaluate f of 2, you would look right here. Does that make sense to us here? That's a piecewise function. Right? This you could evaluate using a graph the same way we did yesterday with just the functions, or well, last time I saw you on Friday. All right, so that's an example of piecewise. We're going to get some more practice with these today here.